Imagine this. Instead of scrolling for answers on your phone, you're teaching an AI how to solve a problem. Sounds wild, right? But that's exactly what a groundbreaking study is testing, turning students into AI instructors to deepen their own learning. Let's dive into how this works, why it matters, and what it means for the future of education. Most AI tools in classrooms act like tutors. You ask a question, and they spit out an answer. But here's the catch. When students rely too much on these tools, they risk becoming passive learners. They might memorize solutions without understanding the why behind them. This study flips the script. What if students taught the AI instead? Enter Socrates, a system designed to make this possible. The key: crafting questions that are just hard enough for an AI to stumble on, but manageable if a student breaks them down. Think of it like a puzzle. The AI can't solve it alone, but with your guidance it can. Students use techniques like chain of thought, thinking through problems step by step, and few-shot prompting, where they show the AI examples of how to solve similar problems. But here's the clever part. Socrates doesn't just take the first answer the AI gives. It tests it repeatedly, using a strategy called self-consistency. Imagine asking a group of students to solve the same problem multiple times. When their answers align, you know they've got it. This ensures students aren't just guessing. They're refining their explanations until the AI gets it right. The proof is in the pudding. In a real computer science course, students who taught the AI showed statistically significant improvements in performance compared to past classes. And the best part? This method doesn't require coding skills or expensive tools. Instructors can use Socrates with minimal setup, making it a low-cost way to boost engagement. So why does this work? Teaching forces you to organize your thoughts, spot gaps in your knowledge, and think critically. It's the protégé effect, the idea that explaining concepts to someone else, or a robot, solidifies your own understanding. By making students the teachers, Socrates turns learning into an active, collaborative process. This isn't just about smarter AI, it's about smarter students. It's a win-win. The AI gets better at reasoning, and learners become more confident, independent thinkers. And who knows? Maybe the future of education isn't just machines learning from humans, but humans learning by teaching machines. So next time you're stuck on a problem, ask yourself, what if I tried explaining it to an AI? You might just learn something new about the topic and yourself. Ever wondered what numbers would look like if they broke the rules? Let's dive into mixed base representation, a mind-bending way to think about numbers that's like solving a puzzle with clues scattered everywhere. Imagine seeing a number like 1.1 and being told it equals 1.25 in decimal. How does that even work? The trick here is that different parts of the number follow different base systems. Maybe the part before the decimal is in base 2, while the part after is in base 4. It's like a secret code, where each digit has its own set of rules. The challenge: figuring out how the pieces fit together. And here's the cool part. This isn't just about math. It's about teaching AI to think like a detective, uncovering logic instead of just memorizing answers. Now let's switch gears to custom floating point formats, a wild experiment in reimagining how computers think about numbers. Traditional systems use binary, but what if we made up our own language? Picture this: a string like BAAA0 translates to +1 times 2 0, while BAC 1000 becomes -1, 5 times 2 2. It's like decoding a secret cipher, where every symbol holds a clue. The catch: there's no hint sheet. You've got to reverse engineer the rules by analyzing patterns. Is the first letter the sign? Do the next few letters represent the exponent? It's a creative challenge that pushes you to think outside the box, literally. And it's a reminder that even AI needs to learn how to adapt and innovate, not just follow strict instructions. What's your take? Would you rather solve a number puzzle or invent a new math system? Drop your thoughts below. We'd love to hear how your brain is wired.